There are some problems out there that are so huge, so complex, that we call them impossible. Now, it's not that they can't ever be solved, but that it would take our best computers thousands of years to even try. We're talking about things like designing the perfect jet engine, or maybe something a little bigger, like unlocking the secrets of the entire universe. For decades, these challenges have been stuck behind a massive computational wall. Well, today, we're going to watch that wall start to crumble. We're diving into how a totally new kind of computer, quantum computing, is finally starting to solve the impossible. Let's ground this in reality with a question that sounds simple but is, in fact, a multi-billion-dollar headache for companies like Rolls-Royce. How do you build the perfect jet engine? I mean, think about it. The next generation has to be way more efficient, quieter, and safer. And that's not just about bending metal into the right shape. It's about predicting this invisible, totally chaotic dance of air moving at supersonic speeds inside the engine. And that is where things get impossibly complex. And here's the kicker. To really get what's happening with the physics in there, you have to run these monster simulations. But even with the fastest supercomputers on the planet, a single detailed simulation could tie up the whole machine for weeks. Just weeks. In the aerospace industry, where everything moves at lightning speed, that's basically an eternity.
Right, so this delay, it's not just some minor inconvenience. It's a massive financial and creative roadblock, a genuine billion-dollar bottleneck. When every simulation takes you weeks, you can only test a handful of new ideas. That truly revolutionary design, the one that could completely change aviation, it might be out there, but you'll never find it because you just don't have the time to look.
So what makes this so ridiculously difficult? Well, it all comes down to one word: turbulence. The air flowing inside a jet engine isn't a smooth, calm river. No, it's a chaotic, swirling vortex, basically a hurricane in a metal box. To model that accurately, a computer has to solve these enormous systems of equations with just countless variables. It's a job that absolutely crushes even our most powerful classical machines. For the last 50 years or so, the industry's best weapon for this fight has been something called computational fluid dynamics, or CFD. The easiest way to think about it is like the ultimate digital wind tunnel. It lets engineers see that invisible flow of air over a wing or through an engine, all before a single piece of metal has even been forged. So at its heart, CFD is all about using some seriously powerful math to solve the fundamental equations that dictate how fluids move. It's the secret sauce behind not just modern jets, but also weather forecasting, and believe it or not, a lot of the insane special effects you see in Hollywood movies. Okay, so how does this digital wind tunnel actually work? Well, it's basically a four-step dance. First up, engineers make a perfect digital copy of the part, say a turbine blade. Next, the software carves up the air all around that part into millions, sometimes billions, of tiny little digital cubes, creating what they call a mesh. Now here's where things get sticky. Step 3. The computer has to solve the mind-bendingly complex equations of fluid dynamics for every single one of those tiny cells. That's the bottleneck. And finally, if it can get through all that, it stitches all the data together into a beautiful visualization of the airflow. And as you can see, this isn't some new kid on the block. CFD has been the backbone of aerospace engineering for almost 100 years. It is a powerful, mature technology. But for the gnarliest problems, it is slammed headfirst into a computational wall. It's just too slow. The industry was desperate for a new way forward. And that new way? Well, it's here. This is where our story takes a sharp turn from the limits of classical computing into a full-blown quantum revolution. We're talking about a fundamentally new way to process information that isn't just a little bit faster. It plays by a completely different set of rules. So here's the mind-bending part. Your laptop, your phone, they use bits. A bit is like a light switch. It's either off, a 0, or it's on, a 1. That's it. A quantum computer uses something called a qubit. And thanks to this bizarre feature of quantum physics called superposition, a qubit is more like a dimmer switch. It can be 0, 1, or kind of both at the same time. When you link these qubits together, the computer can explore this gigantic landscape of possible answers all at once, instead of plotting through them one by one by one. And that incredible parallel power is exactly what you need for that jet engine problem with its millions of interconnected equations. Now, this massive breakthrough didn't just happen in some lab by itself. It took a dream team, a targeted collaboration between 3 powerhouses. You had Rolls-Royce bringing the massive real-world engineering problem. Then you had Xanadu, a Canadian company building the quantum hardware and software. And finally, Riverlane from the UK, who are wizards at the quantum algorithms and something called error correction. So let's rewind for a second. Remember the original problem? The time it took a state-of-the-art classical supercomputer to run just one of these simulations? It was measured in weeks. Weeks of waiting, weeks of progress stuck in neutral. And here is the payoff. Using a clever hybrid approach, where a classical computer sets up the problem and then hands off the hardest part to the quantum computer, the team ran that exact same simulation in less than 1 hour. Just let that sink in for a second. A process that hogged the supercomputer for weeks now takes less time than a lunch break. That's not just a little faster. That's a potential 1,000-fold speed up. It's a game changer. And look, this isn't just us hyping it up. Lee Lapworth, a top fellow over at Rolls-Royce, called this a huge success. He said it puts them in a leading position as we move into the next phase, error-corrected quantum computers. And that's key because those are the more stable, powerful machines that are going to tackle even bigger problems. You really can't get a clearer seal of approval than that. But here's where the story gets truly staggering. This isn't just about building better jet engines. It turns out the same quantum principles that model turbulent air can be scaled way, way up to model the universe itself. That's right, the exact same techniques that are solving these really tough industrial problems are now being aimed at the biggest questions in fundamental physics, questions that have been completely off-limits for every supercomputer we have ever built. So what are we talking about here? Well, how about simulating the aftermath of particle collisions to understand the forces that hold atoms together? Or figuring out one of the biggest mysteries out there, why there's more matter than antimatter in the universe? Or even modeling how exploding stars, supernovae, actually forge heavy elements like gold. These are the grand challenges of science, and quantum simulation is finally giving us the tools to take them on. And you know what happens when you have a technology that can solve problems on this scale, from jet engines to the entire cosmos? It stops being just science, and it starts becoming an economy. We're witnessing the birth of a new, high-stakes quantum economy being built as we speak. It's a pretty simple equation, really. The ability to solve problems that were previously unsolvable is one of the most valuable things on Earth, and you can bet that investors are paying very close attention, pouring serious money into the companies that are building this future. And you really don't have to look far to see the cash flowing in. Xanadu, the hardware partner here, just announced a deal that values them at around $500 million. Riverlane, the algorithm specialist, they've already locked down over $120 million in private funding. This is not speculative monopoly money. This is the financial bedrock of the quantum revolution being laid down right now. So the big takeaway here should be this. Quantum computing isn't some far-off sci-fi dream anymore. The hardware is real, the software is running, and the applications are already delivering jaw-dropping results. This is the foundation of a new, incredibly high-value industry being built right before our very eyes. Which leaves us with one final and kind of mind-blowing thought. We just saw a problem that took weeks of supercomputer time get crushed in under an hour. So what's next? What about the problems that we measure in a human lifetime? Things like curing genetic diseases, creating personalized medicines from our DNA, or discovering brand new materials to fight climate change. If weeks can become hours, how long before a lifetime becomes next year?
Thanks for watching. Don't forget to like, subscribe, and share. It really helps the channel grow. See you in the next video.